Hi, my name is Taylor Kutsier, and this is my presentation on skin cancer. This is my table of contents, where I'm going to go over the cancer choice and rationale, aneuploidy and cancer, an altered signaling pathway, cancer as a genetic disease, incidence and mortality, risk factors, prevention, and my sources. The cancer choice and rationale. I selected skin cancer as the cancer I wanted to research because skin cancer is the most common type of cancer, affecting millions of people globally each year, regardless of age, skin tone, or background. While basal cell carcinoma, BCC, and squamous cell carcinoma, SCC, are the most common and usually less deadly, these are non-melanoma skin cancers. Melanoma skin cancer, which makes up 1% of the total skin cancer cases, is far more dangerous and can spread rapidly to other organs if not detected early. The high incidence makes skin cancer a significant public health concern. Aneuploidy and cancer. First, how does it promote the formation of cancer? When the karyotypes of cells are aneuploid, it means they have gained or lost whole chromosomes or segments of chromosomes. This aneuploidy causes the overall DNA content of a cancer cell to either double or be cut in half than that of a standard diploid cell. This would cause the cell to produce widely skewed dosages of the proteins encoded by the thousands of genes that were doubled or diminished. Large imbalances like these would inevitably disrupt the work of critical teams of enzymes, including those that have had to do with the repair or disposal of damaged DNA, and would destabilize cellular structures and regulatory circuits. This not only explains the vulnerability increase in cells toward cancer, it also explains how cancer cells, even within the same tumor, can exhibit different combinations and alterations of their chromosomes. Its connection to skin cancer. In melanoma, aneuploidy arises from different errors in mitosis. This includes, number 1, spindle assembly checkpoints, SAC defects, which allow cells to divide with misaligned chromosomes. Number 2, abnormal centrosome duplication, leading to multipolar spindles and unequal chromosome segregation. Number 3, chromosome cohesion defects or kinetochore microtubule attachment errors, which are often linked to dysregulation of Aurora B kinase, or AURKB. Number 4, oncogene-induced mitotic stress from mutations in RAS and other drivers, which can promote chromosomal instability. These errors cause chromosomal gains or losses that are not uniformly distributed across melanoma subtypes. For example, acromelanomas, cutaneous melanomas with chronic sun damage, mucosal melanomas, and uveal melanomas each show characteristic recurrent aneuploidy patterns. An altered signaling pathway. One pathway that is altered in cancer cells, the most frequently altered pathway, is the PI3K/AKT pathway, which normally regulates cell growth, survival, and metabolism. In healthy cells, growth factors bind to receptors, activating phosphoinositide 3 kinase, or P1-3K, which phosphorylates PI1P2 to PI1P3. PI1P3 recruits AKT to the cell membrane, where it becomes activated. Active AKT then phosphorylates downstream targets that promote cell survival, proliferation, and inhibit apoptosis. How does this alteration promote cancer? Number 1, uncontrolled cell growth. AKT activates mTOR and other effectors that drive protein synthesis and cell cycle progression, allowing cells to divide without growth signals. Number 2, evasion of apoptosis. AKT phosphorylates and activates pro-apoptotic proteins like BAD, preventing programmed cell death. Number 3, metabolic reprogramming. AKT promotes glucose uptake and glycolysis, supporting the high energy demands of rapidly dividing tumor cells. Number 4, resistance to therapy. Persistent AKT signaling can make cancer cells less responsive to chemotherapy and radiation. Because of its central role in multiple cancer hallmarks, the P1-3K/AKT pathway is a major target for cancer drugs, including P1-3K inhibitors, AKT inhibitors, and mTOR inhibitors. Cancer as a genetic disease. Cancer develops when mutations or alterations occur in a cell's DNA, disrupting the normal instructions that regulate cell behavior. These genetic changes can be inherited from a parent or acquired during a person's lifetime due to errors in DNA replication, environmental exposures, and other factors. incidence, and mortality. In the United States, skin cancer is the most common form of cancer. Like I said before, it has two different main types, melanoma and non-melanoma. When it comes to melanoma, there are about 112,000 invasive melanomas to be diagnosed. This is a 2026 estimate, plus roughly about 122,680 non-invasive cases, for a total of about 234,680 melanoma cases. For the deaths when it comes to melanoma, about 8,510 people are expected to die from melanoma this year. When it comes to non-melanoma cases, the new cases per year when it comes to basal cell and squamous cell carcinomas are far more common. The medical expenditure data suggests about 6.1 million adults are treated annually for these cancers. However, when it comes to deaths, non-melanoma skin cancers are generally less deadly than melanoma, bringing their annual death count to 0. However, they still cause significant illness and disability. Note, I did not include the new cases for non-melanoma on my graph, simply because it would mess up the proportions and the perception of every other measurement. Risk factors. 3 key risk factors for developing skin cancer. Number 1, exposure to ultraviolet or UV radiation. UV rays from the sun and artificial sources like tanning beds damage the DNA in skin cells, increasing the risk of skin cancer. This damage can lead to uncontrolled cell growth and cancer development. Both sunburns and chronic repeated UV exposure are significant contributors. Number 2, fair skin, hair, and eye physical characteristics. People with lighter natural skin tones, blue or green eyes, blonde or red hair, and a tendency to burn or freckle easily are at higher risk. These traits mean less melanin is present to protect the skin from UV damage. Number 3, family or personal history of skin cancer. Having a family history of skin cancer or a personal history of skin cancer increases your risk. Genetic factors and shared environmental exposures can contribute to this elevated risk. Prevention. The most important measure to reduce skin cancer is the consistent protection from UV radiation, both from the sun and artificial sources like tanning beds. UV rays damage skin cells, leading to mutations that cause skin cancer. While the number 1 most important prevention method is to wear sunscreen or use broad spectrum sunscreen, there are other methods to prevent skin cancer, such as limiting sun exposure during peak UV hours, which is 10 a.m. to 4 p.m. daylight savings time, which is when UV rays are the strongest. Seek shade and use physical barriers like umbrellas or trees. Wear protective clothing such as long sleeve shirts, pants, and hats with wide brims to shade face, neck, and ears. Use broad spectrum sunscreen with SPF 30 or higher, applied 15 to 30 minutes before sun exposure and reapplied every 2 hours or after swimming or sweating. Wear UV protective sunglasses to shield eyes and surrounding skin. Avoid tanning beds and sun lamps as they emit intense UV radiation linked to melanoma and other skin cancers. And lastly, protect children early. Limit outdoor time during peak UV, apply sunscreen, and use protective clothing. These are my sources.